Hey everyone, thanks so much for having us here and welcome to our CS50 seminar. My name is Sane.
My name is Mohammed, and we're here to unpack the black box that is AI, from how it works to how we can apply it to our projects.
So let's dive in with what is AI? There are lots of questions surrounding AI, beginning with, does AI think? And the answer is no, not really. AI doesn't think in the traditional way that humans do, and we'll dive deeper into how this happens in just a second. But next, is AI accurate? And sometimes, yes, it is. It can get pretty accurate. But we do have to take all AI outputs with a grain of salt. It's possible that AI gives you false information with a high degree of confidence. So at that point, is AI even useful? And yes, AI can be so incredibly useful, and it's extremely important to know how to masterfully use AI. But the question still remains, what is AI? At its core, AI, or artificial intelligence, is the ability of machines to perform tasks that typically require human intelligence, whether that be learning, problem solving, or decision making. As an umbrella, AI encompasses a wide range of things, as you can see on this diagram. But today we're focusing on a specific powerful subset of AI, and those are large language models, or LLMs for short. These are the systems that power tools that everyone is talking about, like ChatGPT and Google Gemini.
So let's dive into how these LLMs work. If I gave you the sentence, "Twinkle, twinkle, little," what do you think comes after? Suppose we all had a vote. Perhaps some might say, "Twinkle, twinkle, little duck." Probably not, but if they did, there would be many others who would disagree. They might instead vote that the answer is star, twinkle, twinkle, little star. But there might be others who disagree, and based on different contexts, there are a variety of options we could have. Supposing we all took a vote, we'd get some distribution of words that would allow us to say with some probability what the next most likely word is. At a very high level, this is what LLMs do. The first step to creating the LLMs we have today was simple word prediction. The model was trained on vast amounts of data, pretty much the entire internet, to learn what the probable next word was given any phrase. Simply put, if I wanted to know what comes after twinkle, twinkle, little, the model would check what word came after that phrase most of the time, and choose that word as the next word. So in the beginning, you would not be able to ask questions. You would start a sentence or paragraph, and the model would complete it based on the probability of the next word, and would keep going until it reached a predefined stopping point.
And to be able to make the best calculations to form the most accurate predictions, LLMs need to be trained. Training an LLM is essentially feeding it tons of information, thus allowing the model to build parameters. You can think of parameters as trillions of little dials, which are just really small, lots of numbers, that represent how words are related to each other in the data that has been fed. So now we're at a stage where these models are great at predicting a next word, sentence, or even a whole document provided at a starting point. But how do we go from twinkle, twinkle, little star to answering more complex questions? And that's where fine-tuning comes in. Fine-tuning is the process of taking a pre-trained language model and training it further on high-quality, task-specific data. Once people and companies recognized how powerful these models were at predicting languages, they began creating curated data sets, especially question and answer examples, to help the models learn how to respond more helpfully. And by training on large numbers of these question and answer pairs, the model gradually adjusts to its internal parameters so that when it sees a question or an instruction, it has learned to predict more relevant and context-appropriate responses rather than just continuing text. So in other words, fine-tuning takes the model from continuing sentences to answering questions. Once we have trained the model, the input is what we enter. The processing is the model recognizing patterns amongst our input and all of the data it has trained on, and then the output is the prediction of what the correct answer is.
This process is incredibly powerful, but not without limitations. As a result of the way that LLMs were created, they're susceptible to a few issues. Much of the original content produced by LLMs was complete garbage, referred to as hallucinations. Since the LLM is not thinking, but is in fact simply predicting the next words, it could produce content that is inaccurate. One example is creating references that don't exist, or quoting statements that were never said. Another is to output sentences that just make no sense. Let's take a look at this sentence. To upgrade your RAM, remove it from the computer and soak it in warm water for 20 minutes to refresh the memory cells. The model associates words to predict the next word. And now that you know how this process works, it's easy to see how such a hallucination could arise. Here we see words like RAM, computer, and memory being associated, as well as phrases like remove, soak, warm water, and refresh, creating this funny sentence.
There have been more recent developments that specifically target hallucinations, such as chain of thought and tooling. We know the standard input-output prompting for LLMs, but in order to reduce hallucinations, there's a technique called chain of thought that used to get the model to show its work by breaking up a prompt into smaller logical steps and having the model answer each of them. It's kind of like having an analyst explain their thought process instead of just giving you the answer. Now, it's worth noting that this does not fully eliminate hallucinations, but it does reduce them significantly. Similarly, tooling was introduced to improve the abilities of LLMs, especially when it comes to math. And this might sound surprising, but early LLMs were actually pretty bad at math. And the reason is that LLMs don't really think or calculate the way humans do. And as we learned, they're essentially predicting the next word based on patterns in their training data. So instead of actually solving a math problem like 2 plus 2, the model was just making its best guess at what the next answer should look like, which, as you can imagine, often went wrong. But this changed once we introduced tooling. With tooling, the model doesn't have to rely on word prediction alone. If it recognizes that a prompt requires actual calculation, it can call an external tool like a calculator or a small Python environment, generate the appropriate inputs to these tools, and then receive the correct result, which addresses the previous problem of hallucinating outputs that are very easily calculable. So now, instead of guessing, the model is actually just computing the answer. Of course, while models will no longer get something like 2 plus 2 wrong, they can still struggle with more complex, multi-step math reasoning. Once this idea caught on, though, new tools started appearing very quickly. Now models can search the web for information they weren't trained on, write and run code to produce graphs and perform analysis, and even convert text into podcast-style audio so you can listen instead of read. Tooling essentially expanded LLMs from just predicting text to interacting with the world. A really cool extension of tooling has been to create what are now often referred to as coding agents. By giving LLMs access to a few tools, we have been able to create programs that can write, run, and fix their own code. Although together they are very super powerful, separately the tools are not too complicated. So first, a read and write tool is used so that the model can open your files, make changes, and save them. There's also a run tool, which can be used to execute the code and see what happens. And a third tool is the think tool, and that's used to plan its next step, like deciding which file to edit or what command to try next.
So now that we went over how LLMs work, how can we use it? When building projects, there are many ways to use LLMs, but my key advice is to do 3 things. 1. Experiment. 2. Experiment. And 3. Experiment again. Try out different models and providers, and test out how you might be able to use LLMs in your own workflow for coding, as well as in your code itself. Which model should we use? There are so many great models out there, and it's hard to say which model is the best. You guys are probably pretty familiar with some of these, including ChatGPT from OpenAI, Claude from Anthropic, and Google's Gemini. We also have DeepSeek from China, Llama from Meta, and Grok from xAI. Choosing a model depends partly on your use case, but also partly on personal preference. As a starting point, there are a bunch of developers online who maintain this website called LM Arena. Essentially, they pit the models against each other with a variety of prompts, and will pick a winner each time, resulting in this reasonably accurate and up-to-date leaderboard of which model is the best for each specific use case. As you can see, Gemini 2.5 Pro is currently leading in all use cases, but again, this changes fairly often and personal preference matters, so please do try a few out.
Now let's move on to the applications of AI, specifically how we can make API calls to LLMs. You're probably familiar with this from the finance problem set, but just as a refresher, an API key is like a password that lets one software access another software's services. And an API call is a request one software sends to another to get some data or perform an action.
We're going to show two examples using the OpenAI API to show you how you might use it in your own project. Do be wary that the syntax may change, as it is constantly being updated, and make sure to check the docs for the model and provider that you are using. For our demo, we will use the API for two projects that are structured in similar ways to the finance problem set, using Flask, Python, and HTML.
So let's begin by seeing how we can generate and retrieve an API key from OpenAI. First, make your way to this link. This is where OpenAI allows you to create your own API keys. Feel free to log in, and then you'll land on this following page. This page will show you a list of your previously created keys. Notice that I blacked this section out from my screenshot because it's extremely important that no one else sees your API key. And that's because anyone who has your API key can use your account services and possibly your money and data as if they were you. So once you're ready to make your API key, go to this top right button to create a new secret key. And once you click on that button, you'll get this pop-up screen. Feel free to name your API key, and although it says optional, I personally find it very helpful to know for which case I've used my API key for by just naming it something. And most importantly, make sure to save your API key somewhere, as it will not be shown ever again once you've been shown it the first time. So you can use your Notes app or anything else, but just make sure you have it somewhere stored. Now let's talk about what a .env file is. A .env file is where you put your API key. It's a hidden file used to store sensitive information like these API keys, passwords, or configuration settings. So instead of writing these values directly in your code where people can access it, you reference them from the .env file so they stay private. And this is important because it helps you prevent from accidentally exposing important credentials when sharing your code or uploading it to GitHub. And by the way, make sure to check our seminar on how to get good at GitHub from 2 years ago. But making a .env file is super easy. All you have to do is to create a new file titled .env in your project root directory, or the highest level of your project repository. And there you can define the different API keys or passwords you can use throughout your codebase. For instance, in this example project, I used lots of API keys from different LLMs, but if you're using the OpenAI API key, you can just define that one variable in your .env file. So now for every time you reference your API key, just use the variable you defined in your .env file. Ultimately, keeping secrets in a .env file protects your account and ensures your app is easier to configure securely.
Is this going to break the bank? Let's have a look at cost. To get to the deposit page, go to Settings on the top right corner and make your way to Billing on the left. Then you can see how much you have in your balance and make a deposit by clicking on the Add to Credit Balance button. You can think of a token as a chunk of text, usually about 3 to 4 characters of English text, or roughly 3/4 of a word on average. You'll notice that the pricing is split into input, cached input, and output tokens. Input tokens are what you send to the model, so your prompt, your system message, etc. Cached input tokens are parts of your input that the API has seen before in the same session, so they're cheaper, and output tokens are what the model generates in response. You're billed based on the number of tokens processed, input plus output, with cash tokens discounted. You'll also notice that the pricing is per million tokens. For requests with GPT-5, generally each one will cost half a cent to 2 cents for a sentence of input and a similar sized response. But they can become expensive with larger input sizes and use at scale. Older and smaller models are generally cheaper, and the speed of the responses may also vary. We will be using 2 projects to showcase how you might work with this API. The first one will be a very simple chatbot, and will just be to showcase the API in action. The second one will be an example of structured I/O, and is a CS50 project idea generator. So let's get into the code.
So as you saw earlier, you have to make a .env file in your root directory. We're not going to show you the actual .env file that we use just because we don't want to share our API key, and this is something that you should also take note of when you're showing your code repository to other people. So here we have a example.env to show you. And this is super similar to the screenshot that we shared earlier, but all you need to do is to define your variable. Here we called it OpenAI API key, just to be very clear about which API key we're using. And here, all you would do is paste the API key after the equal sign. Next, I'll make my way to the appchat.py, and this is where most of our code logic is happening. And I want to point you guys out to this specific line, line 10. This is where we're calling our API key. Note that the syntax might change, so it's really important to keep track of documentation. But as of today, this is how you reference your OpenAI key. You would use the .getenv to be able to reference the .env file to get your OpenAI API key.
After getting the OpenAI API key, we are now able to call the OpenAI API, and we're able to use it to do a variety of different things. Hopefully, this structure will look similar from the finance pset, but essentially here we have a /chat root, and we will have a form in the HTML that accepts information or request from the user. In this case, we've built it as a chatbot, so we have an input text box from the user, and when we get this information of the user message, we will then send that to the OpenAI API. And here's how we do it in the code. I will not go over the specific syntax, as the syntax changes fairly often, but hopefully the idea of how we call the API and how we use this information and then post it to the front end will make sense. So here we have, firstly, initializing conversation history for this session. And we do this so that we can remember previous messages from the conversation with the chatbot. We add the user message to history. And then here we call the OpenAI API. This line of code here essentially creates a chat completions object for the OpenAI API. We pick the model to be GPT-4o. We append the user message history, and then we set the temperature to be 0.7. These settings we won't explain in detail right now, and feel free to look out for other content that will explain this further. We then get the assistance response, and this is the response that we get from the OpenAI API. We add this to our history as well, and then we return the message itself. So let's see how this works in practice. So we'll go ahead and we'll open this terminal. And what we'll see here is that we will run the program as we previously have done before. And let's go ahead and see the chatbot that we opened. And here we go. So here we have the chatbot that we've created, and we can interact with it. And we'll see here that the chatbot responds and is using the OpenAI API to do so. We can even ask the chatbot, "What model are you?" And we should see correctly so that I am based on OpenAI's GPT-4 model, as we use GPT-4o in the code. This is one way that you can use the OpenAI API, and you can use it similar to the ways that you might interact with ChatGPT. You use this in a way where you can communicate in natural language using OpenAI's connection and OpenAI's API, and you use the large language model to do so. Another way to do this would be to use structured output. And so here's an example of using structured input and output using the OpenAI API. And in this example, what we do is that we use both structured input and structured output. And essentially what this means is that instead of just having the OpenAI API output any sort of natural language, we give it a structure that we would like it to output in, and we then use this structure within our application. So here we have the structure of the output schema that we define. And so we have a title, a description, a difficulty, and some other features as well. And in this case, we have a bit more of a complicated prompt. So here in the prompt, we take in structured input and we say, generate a CS50 final project idea based on the following: the student's interests, and here we pass in the structured input of interests, experience, and project type. And we'll get this from an HTML form, similar to how you might have done in your finance problem set. And we create a detailed, feasible project idea based on a couple of important constraints. What we then do is similar to the previous case where we call the OpenAI API. We call this again, but we ensure that the output is going to be structured in this specific way. And here we call these specific parameters once again, as we previously defined in the structure schema. And these output parameters are then used within our application. What does that really mean? What that means is that in our HTML, so let's go over here to our HTML, the structured output is going to be used in some way. And so we've got this form that is going to generate a project idea, and then it's going to pass the structured output into the project idea. So you'll notice here that we have these different elements of our project idea. And each of these elements is going to be passed in by the structured output. So these are some of the input fields over here. And so this is some of the information we'll put in. Thereafter, we will click on the Generate Project Idea. And then we will have the generated project using the structured output that we get from the OpenAI API. So we have description, technologies, key features, and learning outcomes. So let's go ahead and see that in practice. And so we will go ahead and run Python app structured.py. And we'll go ahead and open that. And here is the project. So we have the CS50 project idea generator, and let's see the structured output in action. So some of my interests include 8-ball pool, chess, and I'll say tennis as well. And I'm going to say that I'm looking for an advanced project, and I'd like it to ideally be a web application. And we'll go ahead and generate our project idea. And what we'll see here is that the entire project idea is generated. And you'll notice that we have a variety of different elements, and these elements come from the structured output that we've requested from the OpenAI API. So we have a description, we have technologies, so this is the tech stack that we will be using, the key features, and the learning outcomes. We can also then generate another idea. But hopefully through this process, you've understood how we're going to be able to generate different sort of projects and how you're going to be able to use the OpenAI API for your own projects, either as a natural language output or as structured output for different purposes.